Hi everyone, welcome to today's webinar, Best Practices in Database Deployment Part 1. Today, Grant Fritchey is going to be running through the most common problems and pitfalls of database deployment. This week we'll focus on the process, and then next week in Part 2 we'll guide you through automating your database deployment process itself. So anyway, let's get started. Over to you, Grant. What are we going to be doing today?
And it's a SQL Server webinar. We're going to be talking about databases. Let's talk about specifically what we want to talk about and our goals today. I've got three really simple ones. It's not complex. Basically, I want to talk about your deployment mechanisms, how you do database deployments. Now, we are going to talk somewhat about the methods for automation of this process and why you would automate this process, and we're going to talk to you about knowledge of how to test your deployments. But what we're not going to be talking about today at all in any way, shape, or form is tooling. Today is strictly about deployment methodologies, about deployment mechanisms, and about all the ways and best practices that you guys should be following to get good, accurate, safe, oh my gosh, safe deployments with your databases. So let's get going. So I like to tell a story about the database problem. I had a development team, great bunch of guys, very smart, capable. You know, I'm not complaining about developers, but they had an interesting take on things. And the take was, they walked up to me one day and they said, okay, so we're starting a new project and we're going to need an information persistence layer. And I was like, okay, I'm not sure why you're talking to me. I handle the databases. I'm working in SQL Server. I'm like, yeah, that's what we need. We want you to create an information persistence layer in SQL Server. I'm like, well, okay, so you mean a database? No, not a database. We don't want any databases connected with this project in any way. But we're working with SQL Server and we need an information persistence layer. And so now I'm utterly confused. So I'm like, well, are you talking a reporting system? They're like, no, an information persistence layer. I'm like, okay, did you guys mean analysis services? Are you guys looking at cubes? Or no, we're not. We just need an information persistence layer. I'm like, okay, so you want SQL Server, but you don't want a database. Nope, no databases. Are you going to have tables? Yeah. Are the tables going to have columns? Oh, yes. And into the columns and tables, you're going to be stuffing, varchar and date time and all these things. Oh, yeah. So you want a database? No, an information persistence layer. And here's the deal. What is that they had just become so overwhelmed, angry, completely just unable to cope anymore with the database that they just didn't want the word. And they kind of felt that if they eliminated the word, they would eliminate the problem. And so they had an information persistence layer, not this whole database thing. And the reason that had become such a problem for these guys is that developers, and God bless them, they are right in believing this, have a tendency to look at code as this completely replaceable, instantly, if it's broken, fix it, make it go away, and put a new one in its place kind of thing. And it is. But there's a problem with an information persistence layer, or a database, if you will. A database has this stuff called data. And it's a weird thing, a very weird thing, but businesses have a tendency to like that data. They have a tendency to prefer to have that data around all the time. I was working for an insurance company. We had data that we were legally obligated to keep that was over 100 years old. So that data had outlived probably multiple paper storage systems and had definitely outlived multiple digital storage systems, but it kept going. That data was living forever. Right? And as far as we're concerned, I mean, 100-year-old data is old data. So that stuff had to be kept around. And unlike code, databases cannot simply be replaced. Once you put data into a database, once you've got information persisted there, you can't simply replace it. You have to keep it in place. You have to keep it accessible. And that is the beginning of that problem. That is the beginning of the issue that developers have with databases. I completely understand, I completely sympathize with their issues with databases, but it's also understanding that businesses demand that we keep that information around. So we can't just drop and recreate the database every time we need to make a change to it, unlike how we do with our code. And that's the beginning of the problem. The next part of the problem, which is as big or bigger, is this whole object relational impedance mismatch. The concept that you can create a series of objects in your code, but they don't map directly to storage inside of a database. They can, but frequently those systems are very, very difficult to report on because the storage of an object is very different than relational storage. And so what you get is like ORM tools, object relational mapping tools, which when used properly allow you to map between an object type of storage and a relational type of storage. But a lot of times what I've seen is people, developers again are so angry and so upset with databases and so over the concepts and the problems that databases and frankly DBAs have introduced to them that they override that and they more or less turn it into an OOM, which is object-to-object mapping engine, and you end up with other problems there. And so those are the database problem can be boiled down to those two things. I mean, there's a whole slew of other issues in and around it, but the two issues are the fact that you've got to maintain that data forever, and the fact that the mapping between your objects and your databases is very, very difficult. So that's the problem. That's the difficulty. Let's talk about the solution. And the solution is not complete, and it can't be. Because the fundamental issue is that we still have to maintain data. But the idea is, as much as humanly possible, what we want to do is treat the database like code as much as we can. Now, I realize there's issues and there's bits and pieces and things that aren't going to quite fit that paradigm, but the majority of it can and does if you work at it. And so my concepts are pretty straightforward. What I want to do is treat it as much like code as possible by working directly with the development team. No more of this, throw things over the wall to them, they throw things over the wall to us. Get right involved with them. If you are building systems, build systems with your development team. You need to define a process of deployment that is completely and utterly repeatable. It can't be utterly manual. If it's, a complete manual process, you cannot do the kinds of advanced mechanism needed to support development teams who are doing development in systems today. You need to put that database into source control. I don't care what your source control is. If you're a Mercurial person, excellent. If you're a Git person, because Git does everything including make coffee, excellent. If you're still stuck in VSS, I feel so sorry for you, but that's still a source control system, and it does work is a big word, but function, I don't know. It does do source control. Let's put it that way. Get that database into source control. Get tests on the database. Have tests in place that allow you to validate that your deployments have not broken code, that what you deployed is what you expected to deploy, and then automate, 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 automate. Automate this process as much as you can, because the more you can automate it, the less manual it becomes and the more repeatable it becomes. You can have a repeatable manual process, but it can take you hours, days to get the job done. You make it automated, and you can cut that time down to minutes and seconds. And here's another thing about databases and a solution for how to build and deploy databases. Developers are extremely smart and capable, and developers have spent the last 30 years, 40 years more figuring out exactly how best to manage their code, how to build their code, and how to deploy their code. And they've got all kinds of excellent mechanisms around this, and they're constantly refining them. New ones are coming out all the time. I mean, the whole agile movement is an amazing leap forward in getting better and better code out the door faster and faster. It's an excellent, excellent paradigm, and there are other paradigms being followed. Test-driven development, feature-driven development, all these different things that come up, and they are all about developers figuring out how to do development, which is cool because the DBAs have spent the last 30 years or more figuring out how to protect data, how to have always on, how to have backups in place, how to have mirroring in place, getting the reporting in place, tuning the queries. We've spent a lot of time around protecting that data. What we haven't spent time in is figuring out how to deploy databases. That's been a very secondary thing to us, if secondary, maybe third, fourth, or fifth. So here's an idea. Let's piggyback on the fact that developers are terribly smart, terribly capable, and follow their paradigms. So whatever your development paradigm is locally, whoever you're working for, wherever you're working, if they're following a Scrum methodology, if they're following Agile, if they're, whatever that they're doing, piggyback on it, follow along behind it. Set your system up the same as theirs. So let's talk about this whole concept of process. My belief, and it's my sincere belief, is that process is very much team glue. It is the process that allows a team to function. Now, when you're talking about a team of 2 people, let's say, you don't really need much process. You turn around to the person behind you and say, hey, I'm working, I'm going to deploy the database now. Are you ready? And they say yes. Cool. Now, as soon as you add a 3rd person, things get complicated. A 4th, a 5th, a 12th. Things are more and more and more complicated. And then when you add in multiple teams that have to get alerted that there's a web server team, a storage engine team, the server team, the database team, the development team, QA, God knows who else has to get involved in this, things get more and more and more complicated. And so what you need is a process. Now, I'm not going to tell you a specific process. I'm not. Whatever process that you guys come up with is the best one for you. It's literally something that you'll need to figure out, something that you'll need to define, because your local systems are different than mine. So I can't tell you, here is precisely how to do your database deployments on a Tuesday afternoon at 3 p.m., blah, 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 blah. I can't do that. It's up to you guys to figure that bit out. But here's a very, very strong suggestion. Once you define whatever process it is, this is how we will do our database deployments, make sure that you get management buy-in. And the best way, the very best way to get management buy-in is to write everything down and get people to sign it. There's just no other way. You have to do it. Once you write it down, also make sure it's accessible to everyone. Don't make it like this private thing. I did work for one organization. They had a deployment mechanism, but it was handled by the deployment manager. And the deployment manager knew everything, and no one else knew anything. And we all had to go to the deployment manager to find out what we were supposed to do and when we were supposed to do it. And it was really crazy stupid, because then we never knew exactly what was going on, and it turned into what felt like an incredibly manual and arbitrary process. So if you get a process, publish it. Make sure people know about it. Review that process regularly. I mean, just because, I can't tell you the number of times I've either been working at an organization or walked into an organization doing consulting and said, geez, why are you guys doing this? And the answer is, well, we've always done it that way. Oh my God. Well, if you're doing something crazy, or if you're doing something stupid, or if you're doing something painful, here's an idea: stop. Stop doing that and change it. So if your process is not working for you, review it and change it on a regular basis. Don't be scared to make changes to that process. One of my favorite stories is, it's on the next bullet point: follow the process. Whatever the process is, you've written it down, you've published it, you've got management buy-in. Good. Exceptions need to be exceptional. One of the teams I worked with, we sat down, we figured out exactly how we were going to do it, and the whole concept was that we were going to do 2 deployments a week. It was going to be Tuesday and Friday. We will do deployments, we got it all nailed out. Monday morning rolls around, I get a phone call. We need a deployment. Like, okay, well, tomorrow morning we're getting a deployment. No, we need one now. Okay, fine, exception to the rule. We'll get a deployment out because you guys need one. Cool. We did the Monday deployment. We did the Tuesday morning deployment. Tuesday afternoon, I get a phone call. We had a problem with the deployment this morning. We need to do another one. I'm like, well, no, the way we agreed to do it is we would only do deployments Tuesdays and Fridays so that, it cuts down on my time so I have time to do all the other work I need to do, and also so that you guys can, have a stable platform. Remember all those things we talked about? And they're like, oh, yeah, but this is an exception. I'm like, well, okay, but we had an exception on Monday. And like, yeah, this is just another one. Okay, cool, fine, I'll do the deployment on Tuesday afternoon. Wednesday morning, guess what? Another deployment. At which point I said, okay, remember that part where we were going to review our process? I'm now saying that you guys get to do deployments whenever you want. I'm going to write that into the process, and I want it signed off by your manager. And they're like, oh, no, that's not how it works. I'm like, well, that's how it's working. And so we went back and forth and finally nailed it down to we gave them a slightly more frequent deployment process, but the whole idea is exceptions have to be exceptional, right? If it's something you're doing constantly, it's no longer an exception, it's part of the process. And boy, here's the one that gets me because I'm really bad this way. Not all DBAs are. There's a lot of DBAs who are like, you set down a set of rules, that's all they will ever do. Me, I'm a bit of a cowboy. I freely admit it. I will go into production and make changes if I feel that they are needed, and I have been burned by it and rewarded for it, both. But the thing is that there are a lot of DBAs like that. We have a tendency to act like, almost like doctors, right? We're saving lives. We're that great. But the fact is that we're not. We're not that special. And whatever these rules are, whatever these processes are that we come up with, DBAs, guys, they apply to you, right? You're going to have to follow them as well, and that does become problematic. It does problematic only because we get in habits of not following those processes. We get in habits of cowboying types of things, and so you just need to avoid that, that tendency. I know I'm not alone there. So let's talk about how you define a development process. Now, from most people's point of view, a development process looks something like this. I'm sitting on my laptop or my tablet or my desktop, or I've got access to a mainframe or something, I don't know, but I'm developing away. I'm having a blast, I'm writing code, it compiles, yee-haw, constant affirmation, and then at some point I will do a deployment, and that deployment will go to QA or testing, or financial testing, or integrated, or whatever, but it will go through some sort of a testing process. If there are problems, it goes back to development, developers fix things, and then do another deployment to QA, and on it goes. At some point, we say, yep, this stuff is good enough, and then off it goes to a production. Okay, and so this is more or less a development process. You write some code, you test it, you deploy it, right? That's more or less how it works. Here's my suggestion for how you want to look at your development process. Hang on, click one more time. Instead of looking at your development process, and this is especially important for databases and DBAs, instead of looking at this constant stream of change moving up from development, let's look at it from production backwards. Now, production is where the data lives. Production is where the stuff I have to save and protect is, and DBAs, that's your number one job, is protecting that data. Number two is getting successful deployments out there, but you've got to protect that data. So let's define exactly what it is we need to have for a successful production deployment, and then make sure that that's what we get out of the QA testing process, and then feed into the QA testing process whatever we have to do from development in order to make sure that what we ultimately get in production is what we need. So if you really want to break down the steps, it would look like this. So basically a deployment process would be, we have a production deployment script. That's the way I like to do things personally. I like a script. It's a script that I've tested on a copy of production. So I know that that script will not break my production servers. I'm going to have to generate that script from someplace. So I'm going to have to get it from a label inside of my source control. Well, that means at some point earlier, someone has done a label inside of source control. And again, I know that different source control systems call them different things from labels, or, whatever it might be for your different source control system. Just change the language so you understand what I'm saying. And then obviously there's going to changes have going to occur in the source control. There's been changes to the code, and that code was all pulled originally from source control. So if you look at these steps, this is literally backwards from how development actually occurs. But by defining it this way, this is what I need for a successful production deployment. I am protecting the stuff I have to protect. And then feeding it back down the chain, here's what we need to do to generate the thing that allows me to do my deployment. And taking this approach, I've been able to work with development teams much more successfully and get a successful deployment process. So parts of the successful deployment process, let's talk about what we need, some of the quote tools unquote, although we're not talking any specific tooling today. One of the tools you're going to have is source control. You absolutely must. The reason being is that you really only have two known states to your system. You know what production looks like because it's there. There's a production database, there's a production server, that's what it looks like, that's what it is. That is a known state. The data is not a known state, granted, because it's constantly being updated, but in theory, the structures and the code that lives there is in a known state. The other known state you have is source control, because you don't know what's on the developer's laptop, right? There may be 3 different versions of the code on 3 different developers' laptop. You don't know what's on the QA system necessarily today, because there was a deployment earlier, but they messed it up, so they did a second deployment, but they didn't pull it from source control because you had a cowboy DVA, or God knows what has happened inside of the QA system, inside of the financial testing system, inside of the staging system, inside of the load testing system. You don't know what's in any of these systems for sure, right? But you know what's in production, and you know what's in source control. And so by getting these known states, you're allowing the ability to couple very tightly between what's in the application and what is in the database. I love this bit because it allows you to maintain your stuff so you know exactly who's done what, who is where, who's made changes to things. And frankly, I like having the auditing because it allows me to know, when Timmy the DBA screwed something up, I get to go and check on him. When Timmy the developer has screwed something up, I get to go and check on him. Timmy is my default word for somebody who screwed something up, name for somebody who screwed something up. But auditing is a great mechanism for being able to know where those changes came from, when they came in, and all that other stuff. And that's all through source control system. Another tool you're going to need is some sort of testing mechanism. And the way I jokingly refer to it is deployment. And the best way to test deployments is to do deployments. And so ABCD, baby, ABCD. Always be continuously deploying. Coffee is for deployers. That's how it works. Always be continuously deploying. You've got to be deploying your systems because you don't know how to deploy unless you've done it 10, 50, 100 times. Further, you don't know that your deployments are working unless you've done it 10, 50, 1,000 times, right? So you constantly deploy, which means setting up things like continuous integration, which means setting up things like unit testing, because you need to be able to move your structures around and then validate. Whoops. Hang on, I got an app I need to close. No more tweets. There we go. You need to be able to validate that the tests and things that you've deployed are actually successfully deployed and didn't break your code, didn't break your structures. And so that's what unit testing and continuous integration is all about. And then finally, as far as testing your deployments goes, you need to test to a copy of production. Now, having said that, if you've got, a 50 terabyte system, guess what? You're probably not going to be able to test to a full copy of production. So you're going to have to test to a limited copy of production. I get it. I'm there. I haven't done 50 terabytes, but I've done large-scale systems, and I understand that you can't always have a full copy of production, but you can still have a copy of the code of production, and you can still at least validate the code, and those mechanisms work. Any kind of production copy that you can make, you need to. Any kind of production validation that you can do, you need to. Okay, and it's just what it's all about. So it's a method of testing deployments. If you remember nothing else from today, ABCD, always be continuously deploying. Now, here's the deal. We all work in this mechanism of where there's multiple environments going on, right? You have development. Development is going on. But the beautiful thing is that every single deployment you do is practice. So you can be developing your software and constantly developing it, and think about this little cogwheel spinning like mad. It's going very, very fast because developers like and should be going very, very fast. They should be making lots of changes, lots of deployments on a very fast moving, no roadblocks, greased skids environment. Great. But now there's a slightly slower cog involved, and that's the QA system. QA is going to be running a little bit slower. It's a bit bigger. It's going to run a little slower, and you're going to see testing. You're going to see validation. But what you are going to definitely see is that all those little changes are coming in development. You're getting a chance to test those deployments, and you're getting to test those deployments a lot, right? Because there's lots of changes going on in development, fewer, but still a goodly number of changes going on in QA, and which spark more changes in development, I hope. Then you're going to get a bigger cog, right? And it's going to be turning even slower. It's going to have fewer deployments, but still a goodly number of deployments. And these deployments are going to be much more stable, much more tested because they've passed QA. The staging environment is probably a copy of production, some type of copy of production, whereas development and QA may or may not be, probably aren't, might not be, I don't know, depends on your system. But staging must be a copy of production. So you've got this spinning thing going really fast in development. It's slowing down a little bit in QA, slowing down a bit more in staging, and then finally it's going to land in production. It's not going real fast. You're not seeing lots and lots and lots of deployments necessarily, but the deployments you do see are successful. And they are successful because you've done hundreds of deployments over the time, okay? So it's just this constant feedback that you have to have. Now, we talked about it before. The whole concept here is that you want to integrate your database with the application. And the reason being is that the developers know what version of they're releasing. It says 3.1.2.27. Great. What version of the database is it? That one. Right? I mean, you don't know frequently. But if you've got your database code in source control, if you've got your application code in source control, and you've got them both where they're labeled together, so you are seeing common stuff coming out in a common way, you will know what has been deployed. These things get deployed together, and they're labeled together in order to maintain that integration, in order to ensure that you're seeing the same stuff going out. And that way you'll know that database, this database is on the same version as the app code. And this is a strong recommendation, nothing you have to do, but I recommend deploying the database first. The reason being is that the database is most likely to fail, just flat out, right? No matter how much you've tested those scripts, you may hit an issue. You may not have been able to test on a data copy of the production server, and therefore you didn't spot a data problem, and so you're going to have to roll back your deployment. Deploy that database first, validate that it's in place first, and then do application code. It just makes rollbacks a little easier. If you deploy application code, then database code, and then heaven forfend, turn the app on, new data is coming in, and now the next fixed deployment is that much harder. Right, so you're going to have to be careful there, and so I just recommend getting the database deployed first. But that's just all integrating those two things together, the application and the database. Humans, who needs them, right? No other way to look at it. Too many Timmies in the world. Remove humans from the equation. And the way you do that is through a human process. You automate stuff. And the beauty of automation, though, is that it makes things repeatable. Because if it's a piece of code that's running your deployment, then that piece of code guaranteed is going to give you what you need, right? And if it doesn't, you change the piece of code. Just take the humans out of the equation. Also, generally, automating processes speed them up, right? The more things that you can have just run are going to run as fast as the code can run them, and it's going to run faster than human beings can click their mouse or type, right? So you do the typing once, you create the code, you write the PowerShell script, you create the T-SQL script, you write the .NET code, the Ruby code, I don't care what you're using, but you take advantage of the tools you know to make sure that you automate this stuff and make it set up so that you can get what you need to get done, right? It's not that hard, but automation is definitely part of the key. If you're not automating your deployments, at least up to production, I'm a paranoid control freak jerk of a DBA and proud of it, right? Absolutely proud of it. So I like to deploy a script to production. I don't like automated deployments to production. And that's just a personal preference, and it's one I've been living with, and it's one that served me well, but it makes me a tad bit of a Luddite. If you want to automate your deployments through production, more power to you. I'm in favor of it for other people's stuff, not mine. But as much as you can deploy it, automate it, you should. And as much as you're comfortable with, you should. All right. Let's get a summary here in place. So, running through this, what we want to do is we want to define a local process. I don't care what the process is. It's your process. You need to work with your development teams, with your management teams, and possibly with your business teams to come up with a mechanism that allows you to do your deployments in a timely manner, in an automated manner, in a manner that allows an integration between development and app code. So it's your process, you define it, and frankly, using whatever paradigm that your application development team is using, right? Define that process. Second, work backwards from production. We are DBAs. Our #1 goal is protection of the production system. So keep that in the forefront of everything you do in defining this deployment process. Make sure that DBAs work backwards from production. Protect your production servers, and then figure out how to do deployments, right? And that way, you're serving both the teams that you need to serve. Your business, who expects you to protect that data, and your dev teams, who expect you to come up with a good mechanism to get their database changes and their code changes out into production. Get your database code in source control. And by code, I don't mean just store procedures and views or CLR code. I mean structures, the indexes, the tables, the columns, the constraints, the rules, the defaults, everything. Get it all into source control, okay? Because that way you can make sure you've got the versioning, you've got the auditing, you've got everything in place. I can't emphasize this one enough. Walk down the hallway and talk to your development team as much as you can. I mean, I've had development teams that basically banned me from the room. Some of them I had it coming. Some of them I didn't. But anyway, as much as you can, integrate tightly with that development team. Figure out what their processes are and follow it. Integrate your app code and your database code and their app code directly. Get into how they do things and understand why they do things so that you can integrate directly. Test and validate everything that you're doing. Set up those unit tests. Set up continuous integration. Set up mechanisms that allow you to validate and run your deployments 1,000 times before you ever get to production, so that you know that production deployment is going to work without a flaw. And then again, automate. Get everything running in an automatic fashion. It wouldn't be a presentation without the phone going off. And so that's basically it. Define the process, work backwards from production, database code and source control, integrate tightly with the development team, test and validate all your code, and automate as much as possible. Hopefully today in this somewhat limited presentation, I'm going a little faster than I meant to, sorry about that, I get excited. We covered these goals. Understand how to create your deployment mechanisms, learn about the tools available for automation and deployment process, and acquire knowledge of how to test your deployments. My main goal here really is trying to get DBAs who are working with development teams to work with development teams. Guys, you need to work with them. They are smart, capable people. They're doing good work. They're not against your database. They don't hate you. Well, they may hate me, but they don't hate you. And it's okay to work with them, right? I give you permission. Go do it, all right? Let's open it up for questions. Guys, can you handle that bit? Or should I?
Yeah, sure. So if you'd like to start asking questions, feel free to type them. I guess the first question we've had is, what could you provide examples of the process changes?
Examples of process changes?
Yeah, so the question came in at like 1612, so it's one of the early slides where you had to define a process.
Well, I mean, in terms of a deployment process, the general idea is like what gets deployed where, when, right? So by definition, we're saying, you know, there are, you know, let's put it this way. Start off with continuous integration. So you're doing development and you're doing database development. And so any change you make to your database goes into source control, or, you know, assuming we've decided to go this route. Once anything is committed to source control, and anything committed should be tested first locally, right? So you validate locally that it works, you check it into source control. Once it gets checked in, you should then immediately get a, you know, like either immediate or say once an hour or once a morning. You should get a continuous integration deployment, a full-on database deployment that validates all the changes that have accumulated so far. And it's not to a production system, it's not to a QA system, it's not to anything that's going to hurt anyone directly, but you need to then come up with a process that says if that build fails, you have to immediately figure out why it failed and fix it. And so all of these are part of defining your process, is writing down all these mechanisms of how you're going to handle your code. And now the stuff I described is an approach that a lot of the agile guys take when they're doing their stuff. They have this concept of continuous integration, which is a thing that just constantly validates the code. And so that's what, you know, that's what you would be going for your database too. Same idea.
Okay, Grant, we've had a couple of questions around the kind of the preferred tools of choice. So that's a question basically,
well, you know,
politically correct and state what your preferred tools of choice are. And then more specifically, source control software for SQL Server 2012. Is there any source control software for SQL Server 2012 that you'd recommend?
Okay, we'll do source control first. Any of them, honestly. I've worked with TFS personally extensively and in great depth, and it works great. TFS is Team Foundation Server from Microsoft. It is an excellent, excellent tool. I've done a lot of work with SVN. It is Subversion. It is also an excellent tool, and that one, by the way, is free from a lot of places, although you can buy third-party management tools for it. But it's an excellent tool. I have done work with Git. I don't find it to be, you know, the miracle that many of the proponents of it find it to be, but it does do what it does well. It works, and I have no issues with it. I've not worked with Mercurial at all, but I've heard good things. In short, I don't think that there's a bad version control system. Well, okay, VSS is pretty sucky, but that's Visual Source Safe. but it's old. I mean, it's hasn't been written or updated for what, 6 or 7 years at this point. But even that works. So as far as source control goes, the big ones are TFS, Git, and SVN. I think Mercurial's also in there, but any of those would work. How's that?
Okay, Grant. So next question: what have you used to keep database structure changes in sync with? It says OR, maybe ORM. Yeah.
With ORM. Ooh, okay.
Yeah.
Okay. Let's take that as a second question. In sync with source control. There are two tools on the market. I think there's a couple of others, but they're really two. Visual Studio database tools and Redgate SQL. Redgate SQL Source Control. Those are the two tools that do it best. The principal difference between the two. And I work for Redgate, so I've got a strong bias in one direction, but I'm going to be honest here. The principal difference between the two is one works in Visual Studio and does a good job, and that's the Visual Studio database tools, and the other works in Management Studio, SSMS, your SQL Server tool of choice, and it does a good job. That's the principal difference between the two. There's a bunch of detailed differences. Bits and bobs that one does better than the other, or one might have a slight advantage over the other. I'll leave that to a much more detailed discussion. But those are the two tools that you would use. And the real question comes down to, do you want to work in Visual Studio or do you want to stay in Management Studio? And if you want to stay in Management Studio, you go with Redgate. It's that easy. And the beautiful thing is that the Redgate the Redgate software will actually work with Visual Studio structures. So if the application guys are checking their database code in through Visual Studio database tools, you can still access it through the Redgate management tools inside of Management Studio. So it makes it so you can actually work with both if you want. Those are those two tools. Now, integrating with ORM. Oh my God. Well, okay. First is integrate tightly with your development team. That's number one. Number two is get them to do all their stuff through source control. If they, whatever ORM tool they use, it's going to generate T-SQL. Fine, let it generate T-SQL, but generate that T-SQL through source control. The real issue comes down to not version 1.0 of the ORM tool, because that's easy, right? Because you can drop and recreate the database 1,000 times, recreating all the code through the ORM tool, right? It's version 1.0.0.1, right? That first time that you have to retain data and retain structures, you can no longer simply generate code from the ORM tool. You then have to find some mechanism of coming up with a deployment process and a mechanism of generating scripts. And that means getting the developers to not simply generate scripts, but to check scripts in and out of source control so that you can then use your tool of choice to generate the deployment mechanism. And it's frankly difficult, but you've got the first step is integrating with the development team, right? It's not a tool choice, it's a team choice. You have to get in there, and hopefully that answered that question.
Cool. Grant, we've had a question. How would you recommend going about getting an existing database under source control? So now's probably a good time to talk about the webinar next week.
Oh yeah, hang on.
Do you want to advance the slides to one slide for me?
Yep, not a problem.
So we're going to do the webinar next week, which is about how you can kind of put what Grant's been talking about into practice. So Redgate have a tool called Deployment Manager. So it does a free starter edition of it, and then we also have a couple of paid for too. And as part of an offer for people who have attended this webinar, we're going to give you 20% off the professional and the enterprise editions. If you just email Alex quoting the code webinar 2708. So if you go one more slide for me, Grant.
Oh yeah, one more. Okay, sure.
Cool.
Hang on one second. There.
Cool. So next week is part 2, which is how to use the Redgate Deployment Manager tool, and we'll repeat the offer next week as well, to how you can actually automate the database deployment process using that tool. And it's the same day, same time, and there's a link there where you can register. So back to the question about how you recommend going about getting an existing database under source control. That's one of the things we're going to talk very, very briefly about next week, because until you've got your database under source control, Deployment Manager can't really, it can deploy it, but it's not the best practice way of deploying it. So,
right, and and also getting your database under source control is actually ridiculously simple, especially if you're using one of the 2 tools I mentioned. I mean, it's a no-brainer process. One of the questions was, how do you recommend getting influencing management to change the deployment process? That one's easy, and I've done this one. Document pain, right? Show how much bad deployments have caused downtime. Show how much data loss has been caused by bad deployments. Show how long you spend doing deployments, or how often you have to do deployments, manually. Document that stuff out, and management will pretty quickly identify, places and bits that, oh my gosh, really, we've had 14 downtime, identifiable downtimes in the last 6 months because of bad deployments. Holy crap! I mean, surely at least at one of those, you would get one of the meetings that constantly goes, how can we prevent this from ever happening again? That's usually the time where you step up and go, ha! Let me suggest some mechanisms for, how to do it. And could you be less politically correct and state your preferred tools of choice? I already did. Redgate and Visual Studio, those are the 2 tools. As far as SourceSafe goes, I don't have a preference. Do you have a, let's see, I'm reading through the questions if you guys want to fire one off.
Yeah, so I was going to just jump ahead to one of the ones that I flagged. So what sort of strategies do you use for testing your deployment scripts, especially for large deployments?
Okay. Well, I mentioned several times in the thing was the concept of just testing the script against a copy of production, and that's one mechanism. Another mechanism is the concept of a continuous integration environment. The beauty of a continuous integration environment is there should be no data, right? And so that script, it won't test whether or not your data changed parts of the script are working. Okay, granted, but it will test whether or not creating the tables and updating the foreign keys and creating the store procedures and all that stuff is being done in the correct order, the correct way, and not causing breaks in the code. So those are just right out of the presentation we just finished. Some other details is you look at something like unit testing. Like we have T-SQL-T as a unit testing SQL test as an automation tool around unit testing, and that allows you to write in T-SQL unit tests. Now, I don't recommend writing a unit test for every query you have because actually application code tests are going to be the best for those. But when you get into any kind of complex tests, any kind of complex data manipulation queries, not ones that are just simply running a select statement, but that are doing a lot of work, I would suggest writing a validation test for those in a unit test environment like SQL test. That's another. Another mechanism is simply the Mark I eyeball. Look over the scripts, right? Take a look at them, see what they're doing. Understand, like I said, there's 2 tools I recommend. They are awesome tools, but both tools can screw up. And the Redgate tools can make a mistake. The Visual Studio tool can make a mistake, and believe me, the Visual Studio tools can make some big mistakes. It's pretty cool. When you've got a large deployment, look through that script. Now, when you've got a 10,000 line script, and I've had that, you've got a 100,000 line script, I've had that. It's difficult to look through them. Bring in a friend, but glance through there and understand what it's doing and how it's doing it. That's generally my approach. Hopefully that at least give you some ideas.
Okay, Grant, we've got a couple of questions about kind of basically changing how you work, essentially. So one of them is, in my current environment, I'm the DBA working with the devs up until the staging environment, and then we have another team which handles staging and production. And the question is, I do not have view definition in those environments. how would you handle a situation where you can't see what's going on in staging and production? And I suppose more generally, how do you influence management to change things if anything needs changing?
Well, I mean, that does go back to the management changing things discussion earlier. So those points apply. But if it's literally one of those things where you have to throw things over the wall, again, go and talk to that team. Get a definition from. Treat that like your production environment, right? What is it they need from you to make things work? Okay, great. This is what I will deliver, and how do you need to go about generating that? Again, that whole idea of working backwards, to me, at least to me, maybe it doesn't work for everyone, but it's made my life easier because I understand what it is I have to deliver, and then I figure out how to deliver it, rather than working, well, I've got this tool, let me, figure out what I can do with it. It seems crazy going that direction.
Grant, so we've got a question which is basically about environments being different. So if I read the entire question, so regarding automation, I agree to some extent that things should be automated as much as possible. However, I certainly want to comment not to totally eliminate manual intervention. For example, we faced a lot of occasions where the automation script worked fine in one environment but didn't work in another one. We faced different sets of issues in the different environments. This caused an issue for us because people were not in the office and we had to work out what was going on. So what can you do when environments are different?
Okay, yeah, that's definitely one I've run into 1,000 times. I mean, the dev environment is different from QA. QA environment is different from staging. Staging is different from production. If in nothing else, in security settings, right? Development, in theory, and I advocate for this. Developers have full control. Let them do anything and everything. And if they drop the database too often, if you've got a Timmy working for you, sooner or later the other developers will have a blanket party or something. I mean, it will get fixed. But let the developers have full control. QA clamp down the security in order to generate those errors, right? If somebody's written code that's not going to meet what it needs to meet in production, you want to catch the errors as early as humanly possible. So you clamp down somewhat in QA. Now, granted, the QA team may have more access than they should have, but then you clamp down more in staging. And as a matter of fact, again, make staging as much as possible a mirror of production. And yeah, you're going to hit errors, guaranteed. I know you will. But that's why I recommend deploying so frequently. Because the more you deploy, the more you're going to start identifying errors, and the more you'll start to identify patterns to the errors. And as soon as you get patterns, if you're using some level of automation, patterns are the areas where you go and automate. And again, just using security as a mechanism, that's one that I used to hit all the time because developers would create it with the wrong owner. They would create, they create procedures that they couldn't possibly deploy because they won't work, all that kind of stuff. But by stepping through a series of environments, you should be able to identify that before you get to a production system, hopefully. And that's the whole goal of having the multiple environments, is to try to make it like a funnel, so it filters down, so what comes out at the end is refined, is exactly what you want it to be. Yes, you're going to hit errors, but that's the part of the process.
We've had a question about basically lookup reference tables. So what experience or best practices have you had on sourcing data and managing those changes via deployments? For example,
oh man, I can tell you stories. Let's put it this way, that one's hard. I have done it as simply as having a database in production that all the lookups come from, right? And that's just it. So any changes get done there first, so even if you're developing something, you make a change up there and then it's everywhere else. That's got a whole bunch of issues around it, but it's simple. Another mechanism is to actually check the code into source control and make the changes there, and then that way the data lookup data moves with the application data versioned and everything, and you can do that with Redgate tools. That's got some issues just in that lookup data gets big after a while and difficult to manage. I also took part in building a rather convoluted, insanely large management system around lookup data, where we had a database and application and source control dedicated to nothing but lookup data. And that way we could version the lookup data, version it for applications, so like one version could go with one application, one version could go with another application, different versions in different databases in production, different versions in our data warehouse. Oh man, was that a nightmare to set up and manage, but it worked, but it's a heck of a lot of work. Generally, if possible, go as simple as you can, and then get into building the bigger mechanisms. If your data is not too large, I find going into source control is the easiest and the most direct and gives you the most integration. But it's hard. That's almost like a topic unto itself. There we go. I got the words out right.
So I think we've got time for one last question now, which we've had from Brian, which is, what's your take on having unit test objects in production?
Oh, the objects in production?
Yeah, so unit test objects.
So presumably they're stored procedures that are the unit tests themselves. So one thing I should say is we've recently added an option to SQL Compare, which you can, when doing a deployment in SQL Compare, you can, there's an option that lets you configure whether this happens or whether it doesn't happen.
Oh, cool. I love you guys so much. I love you guys so much. You do things that I want without me asking. It's so cool. Personal preference? No, I would not want any of my unit test stuff in production. What should be in production is the stuff that needs to be in production, the stuff that should be in production. I would not want that stuff to be in production. Personally, that would be my preference. However, I'll be honest, it's a hell of a lot easier if you just say, if I've got 50 objects in the database, regardless of what they are, I've got 50 objects in my production database. That is easier. But easier is not always better. Easier is not always best. And the fact that you guys have made it so that we can eliminate the that stuff is great. And have I used SQL data tools? Yes, extensively. I had a push-button deployment process set up for SQL data tools. They are awesome. I don't think they're as awesome as Redgate tools, but they're very good. I just wanted to answer that one because I just saw it.
Cool. No, that's awesome. So there's one final question that we've had, which I can answer really easily, which is, will this recording be available? Yes, it will. It will be available on the Deployment Manager blog, which you can find at futureofdeployment.com. We'll also be sending out an email to all attendees with a link to the recording when it's available. I guess the last thing to say is that we've obviously got part 2 of this webinar next week, where Dave will be taking you through the process of automating your database deployment. Again, that's same time, same day next week.
Yep, absolutely. Same time, same day. We will recap a little tiny bit of some of the stuff we covered already today. But other than that, we're playing with the code next week. All examples all the time. Yeehaw!
Awesome. Well, thanks a lot for attending, everyone, and see you next week.